Okay, so I got a really quick video for us today. We're just going to get a little bit of review for, of course, our quiz today in trigonometry. So here's the name of the game today. Let's get started. We're just going to do a few extra questions. It's literally just going to be two of them. And then I have a really interesting thing that I'll show you, hopefully help you revisualize what an ambiguous case is of sine law. And then just a heads up that our quiz is going to start at 2:25. Let me just get my pen going here. There we go. Quiz is going to start at 2:25. I'll give you a 5-minute break before that, so you'll have a break at 2:20. Anyway, let's not waste time. Here we go. So first question that we're going to do is find the exact value of cosine 210 degrees. Just pause the video here, give this one a try, and then I'll go over it in a second. Okay, so I'm going to go over this now. First things first, when you're doing something like this, draw out what your angle is. So 210 degrees, if you're to draw that out on a Cartesian plane, it's going to be down here somewhere. So that's 210 degrees. But of course, this is trigonometry. Trigonometry likes triangles, so let's make a right triangle up here. And that tells us that if this is 210 degrees, and this, of course, is 180 degrees, that means this angle right here must be 30 degrees. Now, when you see 30 degrees in a right triangle, a little bell should go off in your head. You should go ding, 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 ding. Okay, because that's a 30, 60, 90 triangle, and that's what we call a special triangle as per what our formula sheet has. If you look on your formula sheet, you'll see that when you have a 30, 60, 90 triangle, the hypotenuse is always 2. The side across from 30 degrees is 1, but watch now, 1 of course is your y value here, so you should make this a -1 because we're going down. And then your adjacent side to 30 degrees is square root of 3. Ooh, oh, I gotta start that over again. Hold on, pen's going all crazy on me here. We'll try that one more time. It's the square root of 3. There we go, that worked this time. But once again, notice x is in the negative section here, so you should make it negative square root 3. So now we have all three sides of our triangle formed. That means we can start figuring out what the exact value of cosine 210 is. So we can say cosine 210, it's really liking doing this today. I don't know what it's doing with that. Anyway, cosine 210 is going to be your adjacent side, because cosine is adjacent over hypotenuse. It'll be your adjacent side divided by your hypotenuse. So it'll be square root 3, but negative square root 3, divided by your hypotenuse, which is 2. So that right there would be your answer for the exact value of cosine 210 degrees. And if you're ever not sure, you can always put cosine 210 in your calculator and then try this and see if it gives you the exact same thing. And of course, as per our cast rule, we know that cosine should be negative down here. The only thing in that quadrant that should be positive is tan. All right, so here's another question. This is a sine law question. Find the measure of side C to the nearest tenth. Pause the video here and we'll go over it in just a minute. Okay, so we're going to go over this now. Side C, of course, is this one right here. Sine law is all about making opposite pairs. So we'll say C over sine of the angle opposite it, so sine 105. This is going to equal another side, ideally one that's known, so 7, divided by sine of the angle across from that, which would be sine 35. So I like doing these all in one go, just because otherwise the amount of decimals you'd have to record would be crazy, and you get a more accurate answer if you just leave it all in your calculator. Just go 7 divided by sine 35 in your calculator, get an answer for that, and take the answer and multiply it by sine 105. However you slice and dice this, you should get an answer rounded to the nearest tenth of 11.8. And it doesn't seem like there was any units on this triangle, so it's not like 11.8 meters or something like that. So that's just where we have to leave it. All right, so that was the last question I wanted to do with you guys, but of course you will have questions about the ambiguous case. So I actually found a really interesting link that kind of helps explain why the ambiguous case is the way it is. So right here what we're seeing is we're seeing a base of a triangle that is of an unknown length. We have an angle given. Notice it's in the bottom left how I always set these up. We have the side across from it that's given, and then we have the other side that isn't across from anything. That's also just stationary there. So this is the same way I always set these questions up. Now, right now with this, you'll notice that that opposite side isn't long enough to reach down to this base dotted line. That's going to be the base of our triangle here. This is like that Ahab case where it's A is less than H, which is less than B. And of course, H refers to the vertical height of your triangle. You can very clearly visibly see in this case that the height of your triangle is much bigger than this opposite side. But if I start increasing the length of that opposite side, you'll notice there comes a point where it's long enough that it's longer than the absolute height of the triangle, So it can swivel back and forth so that you can have one of two different situations. You can have this really large wide triangle here, or you can have this dark blue triangle, which would be our case 2. So really just anywhere within that range, you'll find that you'll have an ambiguous case. So anywhere where you see two triangles formed here, that's an ambiguous case. There's a certain point, there it is right there, where your A value is actually exactly identical to the height of your triangle. So in this case, 4.5. That would only be one case, but you'll also only have one case if you actually get an A value, the side across from your angle given, as being bigger than your other side. And when that happens, notice really there's only one triangle, and I can zoom out here. There's only one triangle that forms because it wouldn't physically be possible for it to reflex backwards and go over here and it still be a triangle, right? Because you need to have that 30-degree angle down in the corner. So hopefully that kind of explains why you have an ambiguous case. Just remember, and maybe I'll just go back to the slideshow here. Just remember that we always can connect our first case to our second case. Hold on, let me just get my pen working again. We can always connect our first case to our second case by comparing the angle of B. Your first case will have an angle B1. Keep in mind that that can be added to B2 to make 180 degrees. Or more realistically, or in a practical sense, you can just say, once you finished, your case 1 is all done, and you're moving on to case 2. Ooh, once again, it's doing it. You moved on to case 2. Basically, you just take 180, subtract away your B1, and that tells you your B2. So when you have your case 2 triangle, which will look probably something like this, I can't get over the fact that it keeps doing that. I don't know why it does that. But anyway, B2 will be in the bottom corner there. That's how you find it. You just have to have B1 from your first case, which would look something more like this, and then you're ready to go. Okay, anyway, so that wasn't really as fruitful as I thought, but hopefully at least those examples I went through maybe just provided a little bit of reassurance. And if it didn't, hopefully you still have some time. For practice, you can work on your homework booklet. Remember, you can't do question 8 or 10 yet. You can only do questions 1 through 7 and then question 9. But if you would prefer to work on some previously assigned textbook questions, at least that way you'll see the answers in the back of the book. Now, the quiz will start at 2:25. That'll give you the better part of about 50 minutes to get it done. And again, best of luck.